Yeah, these surface integrals are actually double integrals. I gave the formula and all, almost all the cases. Double integrals either to determine the area of the given surface or to determine or to integrate a function over a given surface. This is what is double integral. There will be two variables independent. Check it. First thing that I want to do is just integration. Later on, we can use this knowledge and then integration. Maybe I'll extensively, I want to talk about double integrals. Because all surface integrals are double integrals. And change of order of integration. Later on, we'll look into the applications of it. Okay. The first set of problems we are looking at. Again, these are the problems from Chris Jake straight away. Check it. Describe the region of integration and evaluate the following integrals as it is. I'm going to add, I'm adding a statement here. As it is and after changing the order of integration. I spoke about it initially in the classes. Now I'm talking about it in length. Whenever they say that it, through examples only I'm basically talking about, right? Yeah. Integral 0 to 1, integral y is equal to x, y is equal to 2x. Please see this. Specifically, I'm writing it now. The function is 1 plus x square plus y squared dy. Some people give the integral limits as this first and this next outer and then put dx dy. Doesn't matter. It's actually whether it is dx dy or dy dx, you have to evaluate the integral with respect to y first because limits for y are there in the beginning as a function of x. Any such integral, I'm talking about it first of all. Whether they give it as dx dy or dy dx, ultimately this integral should give a constant because it has to give the constant whether they give it as dx dy or dy dx. You have to evaluate this integral as with respect to y first, replace y's with x, ultimately integrate it with respect to x and substitute the limits to get the answer. Here, this is the integral in which 1 plus x square plus y squared is integrated over the surface bounded by, this is being integrated over the surface bounded by, in xy plane of course, x is equal to 0, x is equal to 1, y is equal to x, y is equal to 2x. let me put the region, because describe the region of integration is what is the question. This is x is equal to 0. Y-axis, right? Next one is x is equal to 1. This is y is equal to x. This is y is equal to 2x. Correct? Y is equal to 2x. This is the region of integration. In this region, the function is getting integrated. Now, first y limits we are basically taking. If I means what? Somewhere we start it, extend it between y functions, move such then things from x is equal to 0 to x is equal to 1 to evaluate this integral, or the integral of the function 1 plus x square plus y squared. Any doubt here? Without changing the order of integration, the integral is x is equal to 0 to 1, integral y is equal to x to 2x, 1 plus x square plus y squared dy dx is equal to integral x is equal to 0 to 1. What is it? Y plus x squared y plus y cube by 3 is the integral of 1 plus x square plus y squared with respect to y from x to 2x dy. Just attempting the integration, right? It is integral x is equal to 0 to 1. What are all the functions you get? 2x minus x plus x squared into 2x is 2x cubed minus x cubed. For each term, I'm putting both the limits, plus 8x cubed by 3 minus x cubed by 3. Correct? Dx equal to x is equal to 0 to 1. Simplify. 7x cubed by 3 plus 2x cubed is 13x cubed by 3 na? Minus x. Plus x cubed only. So 3 plus 7. 10x cubed by 3. Check quickly.
X plus 10x cubed by 3.
10x
First
cubed by
is
3
x
plus x.
and then 10x cubed by 3.
10x cubed by 3 dx is x square by 2 plus 10x power 4 by 12 from 0 to 1. So it is 1 by 2 plus 10 by 12. Correct? 10 by 12 is 5 by 6. 5 plus 3, 8 by 6 or 4 by
4 by 3.
4 by 3. Now, we will try to understand the change of order of integration and see also. We will, maybe it is lengthy, but we have to do it. Listen carefully. I'm drawing the same region. X is equal to 1, x is equal to 0, x is equal to 1. This is x-axis, doesn't matter. This is y is equal to x. This is y is equal to 2x. This is the region of integration. In this region, I have to integrate. Earlier, we integrated it with respect to y. That means we produced a vertical strip, then moved it in the horizontal direction. Now, carefully look at it. This is 1, 1, correct? This is 1, 2. Listen carefully. This is 1. This is 2. If I want to change the order of integration, concentrate. Initially, I will produce a horizontal strip like this. Such horizontal strips from y is equal to 0 to 1. Till this point, one integral, this horizontal strip is ending on a different line actually, from 1 to 2. So if we change the order of integration, it will become what? X going from this is x is equal to y. Now here x is equal to y by 2. Integral of x is equal to y by 2 to y. Check it once. At any y, 1 plus x square plus y squared dx. Such thing will go, these limits y by 2 to y are there only from y is equal to 0 to 1. Next is what? Y is equal to 1 to 2 dy. Y is equal to 1 to 2. What are the x limits? X is equal to y by 2 to x is equal to 1. It is terminating on x is equal to 1 line. One is variable, another is constant. 1 plus x square plus y square dx dy. Check it once. Definitely this contains now two integrals. Whatever the order that is given in the problem only is the best here, right? Because it's just one integral. Here there are two double integrals are there. If you evaluate, you should get the same answer. No doubt about it. We should get. Number one. If this is clear, that is sufficient for me. Number two. Integral 0 to pi by 2. Integral -1 to +1. X squared y squared dx dy. Whether it is dx dy or dy dx, it makes no difference because all the limits are constants. It is a rectangular region. X is equal to -1. Check it once. X is equal to 1. Y is equal to 0 x-axis. Y is equal to pi by 2. It's a rectangular region. Whether you take the y first and then move it across, or the integral x first and then move it from y is equal to 0 to pi by 2, it is not going to change. So you can straight away write this as -1 to +1, 0 to pi by 2, x square y square, dy dx also. It makes no difference because all are constants. What is this value? Integral 0 to pi by 2 y squared, x squared dx is x cubed by 3. From -1 to +1 is 2 by 3 now. X cubed by 3 from -1 to +1 is, yes, 1 cubed minus of -1 cubed, which is 2 by 3 y squared dy, which is 2 by 9 pi by 2 whole cubed is that. Y is equal to 0 is the other limit. Even a change of order of integration straight away, just inverting them, right? Next, 3. Integral 0 to 1. Integral x squared to x. Good it is. 1 minus xy dy dx. Region of integration I'm talking about. These are y limits, no doubt about it, right? First integral is y. Ultimately, we integrate it with respect to y and substitute x squared and x, so that what I get is a function of x being integrated from 0 to 1 with respect to x. X is equal to 0, again, y-axis. X is equal to 1, intersecting x-axis is equal to 1. Y is equal to x. Please see this. This point is 1, 1. And then y is equal to x squared, right? Y is equal to x squared. What will happen? When x is below 1, x squared is still less than 1. Because of which it's a parabola actually, which stays below. But after 1, x squared is greater than 1, because of which the region of integration here is this. X is equal to 0 to 1. This is y is equal to x squared. This is y is equal to x. Here, you should always take the strict no to the left to right. while integrating it with respect to surface in the upward direction. This is what is given. If I evaluate this, what will happen? Y minus xy squared by 2 from x squared to x is equal to x minus x cubed by 2 minus x squared plus x power 5. Correct? Y is equal to x squared. Oh, all the terms are there here. So integral dx from 0 to 1. Please check it once. X squared by 2 minus x power 4 by 8 minus x cubed by 3 plus x power 6 by 12 from 0 to 1 equal to 1 by 2 plus 1 by 12 minus 1 by 8 minus 1 by 3. What is the value? Oh, 15 minus 11. 4 by, is it 1 by 6? Eight, 3, 3, 8. Correct or no? It's 1 by 6. 1 by 8. Yeah. 3, 3 by 8 is 3 by 24 is 1 by 8. Yeah.
Yes, sir.
14 minus 11, 3. What is this? If I change the order of integration, you have to take the strip which is horizontal. Everywhere it is from this end to this end only. X to x squared. Sorry, x is equal to y to x is equal to root y. Correct? Y to root y, integral of function is 1 minus xy. Please see this. This is x is equal to y. This implies x is equal to root y plus root y only, because we are staying above. There can be place where you have to take it as minus root y also, right? You should know. Next, 1 minus xy limits are y to root y from 0 to 1. Such strips. Please check whether things are clear or not, right? 0 to 1, which is x minus x square y by 2 from y to root y, which is equal to root y minus y minus y squared. Root y minus y minus y x squared, y squared by 2 plus y cubed by 2. Correct? No? What is it ultimately? Integral 0 to 1 dy 1 by 2 root y minus y square by 2 minus y cube by 6 plus y power 4 by 8 from 0 to 1, which is 1 by 2 minus 1 by 2 minus 1 by 6 plus 1 by 8. It will be 1 by 8 minus 1 by 6, no? Is it right? Check it once. Okay, we are supposed to get, the answer is 1 by 8.
Integration of root y will be y to the power of 3 by 2.
Into 2 by 3.
Keep quiet then. Y power 3 by 2 into 2 by 3. So it is 2 by 3. Same, is it same? Check it. Will it be same again? Is it same?
Yes, sir.
Same, sir. Wait.
Now 16 minus 12 minus 4 plus 3 na? 3 by 24, 1 by 8.
Yes, sir.
Next problem. 4. Integral 0 to 2. Integral 0 to x. Please try this now. E power x plus y dy dx or dx dy doesn't matter. The order of the limits is important. What is the region of integration? These are y limits for sure. These are x limits. X is equal to 0 y axis. X is equal to 2. I don't know how much comfortable you are. If y is equal to 0, this is also 1. Y is equal to x. This point is 2, 2 because x is equal to 2, y is equal to x intersection it is, right? So this is the region of integration for us. According to this, actually take a vertical strip and then move it from x is equal to 0 to 2. It is e power x plus y from 0 to x is equal to, hey, integral of e power x plus y dy is e power x plus y only. Integral of e power x plus y with respect to y is
E power x plus y.
correct, no?
Yes, sir.
Okay. Is equal to e power 2x minus e power x. If I evaluate it with respect to y, it is e power 2x minus e power x. Now it is integral 0 to 2 e power 2x minus e power x. dx is equal to e power 2x by 2 plus e power minus x, correct? E power minus x by minus 1.
E power x.
Oh, e power x, minus e power x minus e power x 0 to 2, which is e power 4 by 2 minus e squared minus half plus 1, correct? So half plus half minus e square plus e power 4 by 2 r, okay, correct only? These are all there in fields also for us, right? Integration. Now, if I change the order of integration, what is it? X is equal to y to x is equal to 2, y from 0 to 2. X is equal to y to x is equal to 2, y from 0 to 2, e power x plus y dx dy is equal to, okay, first of all, e power x plus y from x is equal to y to x is equal to 2 is e power 2 plus y, yeah. Minus e power 2y integral 0 to 2 e power 2 plus y minus e power 2y dy. Am I right? Correct? E power 2 plus y minus e power 2y by 2 from 0 to 2, which is e power 4 minus 1 minus e power 4 e squared e power 2y e power 4 by tell me.
Upper limit minus lower limit.
So
it should be e power 2.
E power
2.
That is okay. This is very good. E power 4 minus e power y, correct? E power 2. E power 2 e squared. Now minus e power 4 by 2 plus 1 by 2, which is again e power 4 minus 2 e power e squared plus 1 by 2. Same thing.